Good morning. So we are going to do 8.3, which is finding the ratio or the evaluation of any trig function using any radius. So last class, we created the unit circle and we talked about the special right triangles, your ratios of your sides, and what a unit circle meant. And then we looked at our coordinate pairs of x comma y. Finding that cosine was x over 1, right? Because the radius was 1, so x over r. And that sine was y over r being 1 for the unit circle. So that coordinate pair for that unit circle we had made, of course, is cosine comma sine. And we talked about that the great thing about the unit circle and reference angles and things like that is now I can say to you, hey, what is the sine of 2 pi over 3? And you would be able to use your reference angle, knowing that is the y over 1, right? Because that's the sine. So square root of 3 over 2. Or you can use your unit circle that you created. I'm not worried about you guys memorizing it right now. So we're going to expand that a little bit, because what if we're not just dealing with the unit circle? What if we have other radiuses? So these are your general definitions right here. Sine is y over r. Cosine is x over r. Tangent is y over x. Think of tangent as your opposite over hypotenuse, right? Cosecant, the reciprocal of sine, right? So we just flip. So now we're r over y, making y not be 0, because otherwise you can't do that division, right? It doesn't exist. Secant is the reciprocal of cosine, so r over x. And cotangent is the reciprocal of tangent, so x over y. And we can use this to go quicker. So let's actually do some of those right now. We're going to evaluate a trig functions given a point. So we are given -4, 3. Okay, so -4, of course, is your x value, and 3 is your y value. Now, of course, to do all of our trig functions, we need to find our r. And to find our r is just like the Pythagorean theorem, right? Think of this. This is our right triangle. If we have two sides, to find the third, we do a Pythagorean theorem. But let's relate it to x, y, and r. So our hypotenuse, which would be the radius, so our r, equals the square root of x squared plus y squared. Think of a squared plus b squared, right? We're just doing it in terms of the circle. So we would have the square root of -4 squared plus 3 squared. Now, I want you guys to think about this, because we make mistakes by putting it into our calculator without the parentheses. -4 squared does not equal parentheses -4 squared. The reason why is because in our calculator, it's just saying 4 squared times -1. And we need those parentheses. So sometimes it's even better just to do it without a calculator. -4 times -4 is a positive 16. And 3 times 3 is 9. Well, that gives me the square root of 25. And that is a perfect square, correct? So the square root of 25 is 5. Now, if it is not a perfect square, yes, we will still have to simplify it and then use that as our r. So now, luckily, we have our ratios down here, so we don't have to look back up there. So we have x is -4, y is 3, and r is 5. So when I look at cosine, I'm going to say 3 over 5. I said cosine, I meant sine. Sine is 3 over 5. Cosine is x, right? So negative 4 over 5. Tangent is y over x, so 3 over negative 4. Cosecant, 5 over 3. Secant, 5 over negative 4. Sorry, it's not writing out nicely, guys. And cotangent would be our negative 4 over 3. Very good. All right, next page. All right, this is relating back to the unit circle because the unit circle is just where r is 1. So it makes everything a little bit simpler. But one of the things that we forgot to do yesterday on the unit circle, which we're going to do now before we do where theta is 270, is we marked down all our coordinates except our axis coordinates. So remember that the radius is 1. So what is this coordinate right over here? It is 1, 0. So in other words, for our unit circle, cosine is 1 at 0 and sine is 0 at 0. We look at our 90 degrees, or pi over 2, what is that coordinate? Well, that coordinate is 0, 1. So at the 90 degrees, cosine is 0, sine is 1. What about at 180 or pi? Negative 1, 0. Right? And then we have labeled for us our 270. So we can either look at our unit circle for this, or we can think of in the next section reference angles. So lucky for us, 270 is on an axis, so we can go to the axis of 0, negative 1, remembering that our coordinate is cosine, sine, if you want to remember it that way, or saying, hey, this is x, comma, y. And of course, since this is the unit circle, our r is automatically 1. Okay. Now, is this always going to be drawn for you? No. So make sure that you are drawing your angle, which we practice in 8.2, right? So we have 90, 180, 270, we're right down here, and that's how we know our angle. We'll practice more angles in a little bit. So sine is negative 1, because that's our y, over a radius, which is 1. Cosine is x, so 0 over a radius, which is 1. By the way, this reduces down to just 0, just like this one here reduces down to negative 1. Tangent is y over x. Y is negative 1, x is 0. Can we divide by 0? No, we can't. So what we usually say is undefined. I say UND. Sometimes you have to spell it all the way out. So it doesn't exist. Let's do our cosecant. So r is 1, y is negative 1. So that also reduces down to just negative 1. Secant, r is 1, x is 0. Oh, we're in that situation again, right? Where we can't divide by 0, so we get undefined. And then x is 0, y is negative 1, which gives us 0. Awesome. Let's do one practice problem together down here. Let's do number 1. So we are given that coordinate of 3, negative 3. So our x is 3, our y is negative 3. So before we find all 6 functions, we need to find our r. And r is the square root of x squared plus y squared, which gives us the square root of, well, 3 squared is 9, negative 3 squared, so negative 3 times negative 3 is 9. So we get the square root of 18. This is not a perfect square, but I do have a perfect square in it. So we're going to have to do our tree. 18 is 9 and 2, and 9 is 3 and 3. So we get 3 square root of 2. That is our r. So when I write down my functions now, I got sine of theta, and sine of theta was y over r, so negative 3 over 3 square root of 2. Yes, this can be reduced. Yes, this can be rationalized, but as of right now that I know of, is our homework does allow this. So we're just gonna keep it easy right now and just do that, okay? If you need help with reducing or rationalizing, remember to call me over. Cosine of theta is x over r. Tangent is y over x, which of course can reduce to negative 1, right? Then we do our other 6. So cosecant of theta is r over y. Secant theta is r over x. And cotangent is x over y. Awesome. So that's what we have to do when we're doing evaluating 6 trig functions from a coordinate pair. All right, we're going to go back to reference angles. Okay. Now, the good thing is what we found out the other day is, remember, a reference angle was from the x-axis. Okay, so these give you a couple things that you can do to find that reference angle, but we're going to kind of explore this out. And with radians, it's really nice because our reference angle is that denominator, right? We found that out yesterday. So find the reference angle to theta. For theta is 5 pi over 3. So the first thing is we want to be able to graph it. We were practicing that in 6.2. So if you look at this, 5 pi over 3, what I like doing when I draw out my angles, right? My angles. I tend to put everything that needs to be in 5 pi, in pi's over 3. So this is 0, right? And a full pi would be 3 pi over 3, where a full circle would be 6 pi over 3. And what I mean by circle is rotation, because we can go over and over and over, right? So if you notice, here's 6 pi over 3, this is 3 pi over 3. So 5 pi over 3 is going to be right in here. Okay, now this comes up later for down here, because it is in Q4, which means after we use our reference angle and everything, we're going to find that sine and cosecant will always be negative, cosine and secant is positive, and tangent and cotangent is negative. Think of your x comma y. X's are positive here, y's are negative. Okay, so this question, all it wanted us to do was find the reference angle. And the great thing is, if you look at this, this is 5 pi over 3. 6 pi over 3. So what is the difference here? The difference is pi over 3. And again, I want to point out we're in quadrant 4. Okay? This will help us later. Now, what about degrees, though? And we have it being negative. Okay, so negative, of course, means we go clockwise. Now, here's how I usually do it. 130, right? Well, this was 0, right? And if I go clockwise to this quarter, this would be negative 90 degrees, right? Because I'm going clockwise. If I go over here, I get to negative 180, that half circle. So negative 130 must be in here, in the third quadrant. So how do we get the reference angle? Remember, the reference angle is that distance away from the x-axis, that angle from the x-axis. So right here. So how can we find that out? Well, what is the difference between 130 and 180? 50 degrees. So 50 degrees is our reference angle in quadrant 3. Now, as you can see, this is not one of our special right triangle ones, and we were still able to use the reference angle, okay? Sorry guys, my nose is running, and this whiteout is bugging me. Okay, I know this is a lot of info right here, but keep in mind, right, your x is positive, your y is positive. Your x is negative, your y is positive. I don't know why I put y, guys. And this helps us with our trig stuff in our next example. Third quadrant, they're both negative. Fourth quadrant, we have positive, negative. Okay. All right, next. We're going to use our reference angles to help us actually evaluate this without a calculator. All right, sorry, get a stretch. Okay, sorry guys. So the first thing we want to do, kind of ignore the trig function right now and draw out your angle. So right now we have a negative 240. So again, we're going clockwise. So again, this is negative 90, negative 180. This would be negative 270. So here we are at negative 240. How do we find that reference angle? Well, again, it's the difference for the x-axis. So if this is negative 240, what is that distance between 240 and 180? It is 60 degrees. So our reference angle is 60 degrees. Okay, so if I think of my reference triangle, right? We have 60 degrees. And you can use your special right triangles for this. You can use your unit circle for this, whatever you need, okay? Now, we are going to do the unit circle, which we know that across from 60 is our square root of 3 over 2. And our x is 1/2. Our radius is 1. So x equals, y equals, and r equals. And we learned earlier that tangent is y over x. So tangent of negative 240 is y over x. Now, here's another thing. I'm going to expand on this more. What quadrant are we in? We're in quadrant 2. In quadrant 2, our x is negative, our y is positive. So this becomes a negative 1/2, which a positive over negative is a negative. We can also reduce this because these 2's cancel, or give us 1, I guess, we can say. So our answer is negative square root of 3. We were able to do that without a calculator using reference angles or unit circle stuff. Let's see what we can do with cosecant for B here. So 17 pi over 6. First of all, we learned a little trick that we can just look at the denominator. So we have pi over 6, right? But let's figure out what quadrant it is in. So we have 0, right? Pi would be 6 pi over 6, which gives us 12 pi over 6. And back over here, another 6 pi over 6 would be 18 pi over 6. Do you guys see how I'm adding 6 each time, each half a circle? So if we're doing 17, we back off 1, right? So we are in the second quadrant again. And if I draw out my reference triangle, pi over 6, pi over 6 is our 30 degrees, remember? So we get 1/2 for across, square root of 3 over 2 for the horizontal. Radius is 1. So remember, that's x, y, and r. Okay, so we're doing cosecant, right? So cosecant of 17 pi over 6 equals. Cosecant is radius over r y. Radius over y, right? Cosecant. Radius is 1. Y is 1/2. Okay, let's double check our quadrant, right? So we have 1, our hypotenuse is always positive, right? Because radiuses are always there. And our y value is positive, so we're positive, okay? No negatives, we're good. Well, 1 divided by 1/2 is 2, and we're done. All right, we're not going to worry about the real life problem. Let's do a couple practice problems, some more down here. Let's do number 5, which is sketching the angle and finding the reference. So this is 210, and we're going counterclockwise. So we get 0, 90, 180, 270. So 210 is in this third quadrant here. Okay, so if we find the reference angle, we need to find the difference between 180 and 210, which is 30 degrees. So our reference angle is 30 degrees. Okay, let's try number 7. We're going backwards on this one. So we have 0. This would be our 9 pi over 9. So 7 pi over 9, negative 7 pi over 9 is in here, right? Third quadrant again. So what's the difference between here? Well, that means our reference angle is 2 pi over 9, right? What's the difference between 9 and 7? 2. Okay, since we did 210 up here, let's do this cosine here. But we have to do negative, so maybe that won't work out well. And let's do one of the odd ones. Let's do number 10 right here. So remember, the first thing I said to you before you figure out your trig is draw your angle so we know where it is. So this is 0. This is 4 pi over 4. We're going to add 4s every half a circle. So this is 8 pi over 4. This would be 12 pi over 4. So that means 11 pi over 4 is right here. Okay, so we're in the second quadrant. That means we have a negative, positive, right? Our reference angle is pi over 4. Think of our special right triangles for our unit circle. Across from pi over 4 would be square root of 2 over 2. Adjacent would be square root of 2 over 2. Radius would be 1. So x, and x is negative here. Y is positive. R is 1. Okay, and we're doing secant, guys, right? So secant of 11 pi over 4. Secant is y over x. Did I do the wrong one over there? Sorry, guys. Sorry. No, this is right. So secant is r over x. Again, if you need help with that, just go back to your beginning sheet. If I can find my beginning sheet, that would be awesome, right? Right here. You can always refer back. Secant is r over x until we get used to it. R over x, so r is 1. X is negative square root of 2 over 2. Now, if I were to simplify this, remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So that would give me negative 2 over square root of 2. Yes, you would still have to rationalize it in some cases, but right now I'm not going to focus on that, okay, guys? So let's try some of those out on your homework on big ideas.